So let's now build an LRU cache. For that, I have started my IntelliJ. I'm going to use Java for this. Please feel free to use any other language of your choice. And I'll use JDK 1.8 specifically. Let me create a new project here. I'll choose Maven and I'll choose Quick Start template. Okay. Okay, so I'm naming my project as LRU cache sample. I'll do finish. This should create a sample project for me. Enable auto import. Alright, so looks like my project is ready. Let me quickly check if there is a sample class put in, if it runs properly. Let me see, it's a sample hello world. Okay. Okay, so our project is set up properly. Let's build the efficient LRU cache version. For that, we discussed already that it is a combination of two components, hash map as well as a doubly linked list. So we'll prepare the node for the doubly linked list. Okay, so let me write a node class. So the property of this node class is it points to the next pointer as well as to the previous pointer, right? And it will store its value as well as the key goes inside it. Let me add its constructor. I'll add a toString method in case we want to print the value of this node. Alright, so overwrite keyword here. Okay, so this is our simple node class, and as we said that it is a one piece within the doubly linked list, so it will point to the next pointer as well as to the previous pointer. So if we want to delete this particular node, then we can always refer to the previous pointer, and the next pointer of the previous pointer we will make it point to the current pointer's next pointer. So the value in between these two nodes is eliminated. So let's try to build our cache now. Okay. So before I build, let me just go over the basic concepts again. So we have two major components in this. One is the hash map, which is like our cache. It will return our get operations in order of one time, so it's very fast. Get and put both are fast. And doubly linked list, this for which I'm going to use the node objects, and deletions are in order of one time, right? So this LRU cache will be efficient and fast. So I will need a hash map object, which is my cache object, and I'm storing the key in it as an integer for simplicity, and my value is the node that I am building. Or let me name it as map only. One of the things about this LRU cache, as we discussed in our lesson, was capacity. So we want to build a cache with some capacity, so that when it overflows beyond that capacity, the elements can be deleted, the stale objects can be deleted. So this dot capacity is equal to capacity. Okay, so I need to declare my capacity object here. Right. There are two important things. I need to store reference for my doubly linked lists also here. So I will make reference to the head pointer, the starting pointer for my doubly linked list, as well as to the tail pointer for my doubly linked list. The reason being, tail is the place where I'm going to add the new elements, the most recently used elements, and head will be the place where the elements, node elements that are stale will reside. So if the capacity of the cache is full, from the head we will start removing the elements. Okay, there are two main operations in the cache. One is the get operation and the other one is the put operation. So this being a simple cache, I'm expecting to return the value as int. So I'll do a get operation and I'll provide the key also as int. So let me provide a default implementation first, then I'll go in the details. And we will have a put operation which will store the values. Okay, so int key, int value. So basically in this cache we are storing an integer key and integer value, and when we provide that key in this get operation, we should be able to get that value in order of one time. Okay, so let's start writing the get operation first. So get operation is simple. First we need to check if the key exists in our hash map object. So we'll check if the key doesn't exist in our hash map, then we just return -1. That is, the object doesn't exist in our cache. So we are providing a key which is not even there. We have not stored that value in our cache. Okay, now if we get a value from the cache, then essentially we have accessed this object. So we need to delete it from its current location and add it to the tail because it is most recently accessed. So instead of putting the implementation here, I will put I'll create two functions where we'll handle this. So I'll say remove node. We'll remove this node from its current location and we will add it to the tail. So these are two methods. So this will remove the node from its current location and this will add the node to the tail. Okay, and then finally we'll return t dot value. That's it. Okay, so now we need to provide implementation for remove and offer method. Okay, so let's try to write the remove method first. Okay, so first we need to check if the node that we are removing is it at the top of the list. If it is at the top of the list, if it is at the head, then the previous value will be null, right? So, and if it is at the center of the list, so the previous element will not be null. So in this case, let's check if the previous element is not null. That means it is at some point which is not at the head location. So it is just below that location or at the center. And then we will just move the previous element, as I discussed before also, that if we need to delete this element, we'll go to the previous element, and the previous element's current next element is this node itself. But since we are deleting this, we will just make it point to the next element, right? So here the previous element's next element will become current node's next element. So essentially it is getting deleted. What if the previous element was null? That is, this particular node is at the head of the list. So our current head, since this node itself is the head, will become the next node, right? So head will point to the next node of this current node. Okay, let's check another condition. What if n.next is not null? So as we discussed, this is a pointer in a doubly linked list. It will both have previous as well as next pointers. So we need, when we are deleting this element, we need to make sure the previous and next pointers point correctly. If the n.next pointer or the current node's next pointer is null, that means it is at the tail of the list. And if its next pointer is not null, that means it is above the tail. Okay, so we need to handle the scenario when it is above the tail. So I'll go to next dot previous. So the next element's previous element points to the current node, but since we are deleting it, so next element's previous element will point to current node's previous element, since we are deleting it. But if this element is at the tail, we are deleting the element from the tail, then essentially tail, which was earlier pointing to the current node, will point to the previous node now. So that means the current node's previous element will become the tail. So we have written the remove method. Let's now write the offer node method, which is basically, we are going to add, so I'll just write the details here. We are going to add element or add most recently used element to the tail of the list, right? So these elements are not the ones that are deleted. The elements at the head of the list are stale elements, and if we need to delete due to maybe capacity being full, that is the place from where we'll delete. So offer node, we will also need to pass the element here that we are offering or adding to the tail. First we'll check if the tail is not null. So if the tail is not null, that means we have an element present at the tail. Then the current element tail.next, because tail exists, then will point to the current node, right? So the current node will essentially become the last element in this just doubly linked list, and current node's previous element will point to the old tail basically, and current node's next element will become null because this is at the tail, and the tail object will now become the current node. Okay, there's one important thing we need to check. If we are deleting the element and adding it to the bottom of the list, we need to check if head is null. That is, our head pointer is null after we have removed the single element. In this case, the head and tail are same. Essentially, there is just one element left. So we have added it here. So both the methods we have completed, one the remove node and offer node. Now we'll try to do the put operation. In the put operation, we will first check when we are adding a new element in whether it exists in the map or not. So we'll say contains key. Okay, so if this key exists, then we'll just update the element and we'll remove it from its current location. We'll add it to the bottom of the list at the tail because it has been accessed most recently. So let's try to get the element. Okay, so here we got that element. Now we'll update its value to the new value we got. Okay, and we'll do the same operations again. We'll remove node So basically we'll remove this element and we'll offer it so that it's added to the tail. So we'll these two operations, as I said before, we'll remove the method from its current location, we'll add it to the bottom of the list. But what if this is a totally new element which was not there in the cache? Before we add this element, we need to check if our cache has reached its capacity, and our capacity we were storing in this variable cap earlier. So if it has reached its capacity, then we need to flush the cache. Okay, so how do we flush the cache? We will just delete the head pointer, basically the element at the head. Delete the element at the head. So we'll say map dot remove head dot key. Okay, so this will remove the element from the map. When we are deleting an element, stale object, we need to remove it from the map as well as from the list. So next we'll remove this object head. So I've deleted this element. So the cache is now clean. Next we will add this new element to the tail. Okay, so our constructor had key and value. Okay, so let's add key and value. All right, so we created a new object. Now we will just add it to the tail because it's recently created, so it was most recently accessed, and we will also add it in the map offer. Note that we didn't delete invoke remove node in the doubly linked list because this is a totally new element. It doesn't even exist in the list. We'll add key, which is the key value we are passing, and we'll add the new node here. Okay, so this pretty much completes our get and put operations. So let's quickly try to test our cache class now. So for this I'll first write a method. This will essentially print all the elements that are present in my cache at that point in time. So I'll just go over the head element and go over all the next pointers that connect to this head element. So essentially I'm iterating over all the nodes and then I'm going to print them as I go through them. So I'll just keep it simple. So I created this toString method in the node class. So I'll just invoke that and I'll just point this to the next pointer. Alright, so this should print my cache, whatever we have in the cache. So for simplicity, again, I'm just testing it from within this class. Okay. So let's say I'm keeping the capacity as 3. Okay. Now let's try to create an instance of this class. Okay, let me pass the capacity to it. Okay, this should create my cache. So first let me just add 3 elements and see the result. Okay, so I'm just adding, say, so essentially there are 3 elements in the cache now. Let me try to print it and see the results. So I say LRU dot display cache. Just we'll run it now and see what is the output. Okay, so I'm getting a null pointer exception somewhere. Oh, okay. So I have not initialized my map. So let me just create a map instance. Okay, this is cool. All right. So let me run it now. Okay, so this is cool. We have 3 objects within our cache. Now let me add a 4th object and see the result. Okay, so I'll give okay. So if I add, say, a new node, a new value in the cache, it should flush out the old value. In this case, this is the oldest value, the first one that was added. So it should delete this value and add the new value because the cache would have reached capacity. There are already 3 elements in the cache. Capacity was 3 and now we are adding the 4th element. Okay, so let's see what is the result in this case. Okay, so we saw that initially there were 3 elements, 1, 2, 3, and 1 would have been added to the head because this was the least recently used, and when we added 4, this got deleted, and now this is the list. Let me add another element. Okay, let me add a new element, say 7. So in this case, when I run it, even this should be deleted next time when 7 is added. Okay, so 2 got deleted, 7 is added. Let me try to access an element and print it. Let me pass the key as 7, and immediately after get I will fire this display cache. Let me first print the value of the get operation. So get should not result in any deletion. Okay, so result. Cool. So let me print it now. Okay, so the last set of results was 3, 4 and 7, and we tried to access this element 7 and we are getting the value as 7 here. And as we can see, get operation, there is no change in our cache, except that since we accessed the last element, it is present at the tail of the list. If I fire a get, say on 3 now, and then print the cache, 3 should come to the bottom, that is on the tail of the list. Let's try to do that before we close this case study. So I am accessing 3rd element, which was at the top of the list, so at the head. So let me try to print it now. Yeah, so if you see here, 3rd element was at the head of the list, but then we tried to execute a get operation and print the result. So since 3rd element was most recently accessed, it was added to the bottom of the list, that is to the tail, and hence 3 has moved to the bottom of the list now. So this completes our lesson for the coding piece on LRU cache. You can download this code directly from the resources on this lesson, as well as it is also put in the GitHub repository. and the link for that I'm sharing in the resources section too.